Hey everybody, I hope you're all doing perfectly swell. So today I'm working on a MacBook A1707 that was sent here after a failed battery replacement. Somebody attempted to replace the battery in this unit and accidentally popped the battery data connector off on the wrong side, which you can imagine is quite ugly. Also, I'm going to be doing this repair entirely off-grid. I've got the entire shop running on this Oscal PowerMax 3600. That is a unit that I'm going to be reviewing in a very near upcoming video, so if you want to know more about that, stay tuned. So here's what we are up against. I'm not sure just how much I trust this battery. However, I can tell you that somebody has popped that connector right off the board, which is probably a fairly common problem, but as you can see, it literally does not have a single pad left. And once I get that repaired, then we've also got the trackpad flex cable to deal with. It was torn off completely right up here where it goes under the battery. Thankfully, that is a replaceable component. So let me show you what it looks like under the microscope. So right here is where that connector should be. And as you can see, there's just absolutely nothing there. It's totally gone. So it not only got popped off the board, but it got like popped all the way off the board. Now, there's a couple of ways we can go about this repair. We can try to solder to the individual vias that are there, which is what I'm going to be doing, or having a look at the board view. Here's that connector up here. This is J6951, and also we're using Flex board view here. I love this software. The first two pins here, pins 6 and 5, those are both ground, so we really don't have to worry about those. We can just, I can grab those right next to the connector anywhere on the ground plane or whatever. Now, we do have to be concerned about pins 1, 2, 3, and 4 though. We've got SysDetect L on pin 1, we've got SMBus, SMC, SCL, that's a clock line. We got SMBus, SMC, SDA, that's a data line. And then we got this TP beam on out. It says TP. Let's just see what we get in diode mode. I don't want to accidentally connect a wire here and not have it connected afterwards. Now, thankfully, we can, like SysDetect L, we can grab that here from this nearby resistor. So if I build a pad up and it loses its connection, we can always put a jumper there. The next pin here, the clock line, we've got that available, all stinking all over the place. So if for any reason I put a jumper on here and it fails, we can actually get, we can jumper that out here from R5381, which by the way, I really like that Flexboard View draws lines for us. And then at the same time, I think just on the other side of the board, there's probably a test point. Yes, we can get to a test point on the opposite side of the board. So we have options for putting wires into these pins. What about our third pin? Literally the third pin. It looks like we've got a nearby test point here, and also most likely just on the other side of the board. We've got other things that we can hook to on the other side of the board. Okay, how about our fourth pin? TP beam on out, which might just be for the test point. It's hooked right here to this test point on the other side of the board. So I could just put wires all over the place on this board, but what I'm going to try to do to make this a little bit cleaner is just hook straight to the via little nubs that are sticking out from the board. Now, before I do this, I am going to check it in diode mode because I don't want to put these jumpers in and then not know for sure that they're not connected. Those of you that watch this channel will know why that is. All right, so I'm putting my red probe on ground, using my black probe to do the probing. I should get 0 at these nubs. I do. I get a 0.00, 0.00. Those are ground. We've got an open line on number 3. That's TP beam on out, which we know by the board view that is only going to one place. That's going to a test point. We could probably leave that one unhooked. We'll hook it up anyways. All right, so then number 1 and 2, I'm getting a 0.43 right here on this one, and then on that's number 2. Now on number 1, I'm getting an open line on number 1. Let me try to reverse my leads. All right, also an open line on number 1. What was number 1 hooked to? I have actually fixed very little on MacBooks. I've actually fixed more USB-C problems than I have physical damage, so If you work on MacBooks every day and you're watching me pick around at this connector not knowing what I'm doing, feel free to laugh. It's completely okay. Okay, I'm gonna check this resistor right next to it, R6950. I'm gonna make sure I've got continuity between pin 1, sysdetect L, and R6950. Aha, there we go, 0.00. So now I know about what we should be getting in diode mode, and let's fix it. So I've been on battery power now for about 2 hours, and I started at 90 or 91%. I'm down to 73%, and it's estimating 10 hours remaining, and the bench is drawing 150-ish, 200 or so watts. That is if I don't pick up the hot air station. If I pick up the hot air station, it starts drawing 1500 watts. So to fix this the most efficient way possible, I think I'm probably going to go ahead and just skip those 2 ground pads because I can jumper those in later. And I'm going to go straight after our active pins, which are down here. And I'm just going to try to clear off as much of these as I can. Well, not as much as I can, but as much as I need to. Ah, yeah, there we go. We're going to go from having a almost impossible to get anything reasonable to stick to nub to having a nice big old juicy fat thing to solder to. Okay, there's that one. It would actually be easier to keep in focus if I had the board out of the housing, but I'm not going to take the board out for this. Not because it's hard, but because I don't want to keep track of all the screws. Okay, now on this one I'm starting to worry that we're not going to have much else to solder to because it's not, I'm not seeing anything else around it yet. Wait a minute. Oh yeah, it's just a little deeper in there, right? There, we're getting there. Okay, there's our second one. Let's go ahead and do the third one and the fourth one. And also just a reminder, you are looking at the tip of a number 11 X-Acto blade. And this board is quite a bit larger than the last board that I did this to. The last video that I had on YouTube of me doing this was an iPhone SE, I think. No, wait, it might have been a 10R. I don't even remember. I'd have to go back and look. I've done so many phones since then. Okay, I'm starting to see more of what I need. Boy, on the MacBook board, it does seem to be that these are down in there pretty deep. Okay. There's number 2. Yeah, I think on the ground ones, pins 6 and 7 there. Wait, no, pins 5 and 6. I'm just going to put wires probably directly from ground plane. I might even just solder the pins on, I'm going to do that after the fact. These are the ones we need for this thing to function. Oh, and ground, just not those grounds. Almost there. Then we get to do the fun part. Wait a minute, it's all fun, right? As long as my battery pack don't go dead. Where am I at? Oh yeah, 72%. That is looking okay. Now I'm going to grab some wire here And we don't have to, I mean, we're not trying to carry any sort of current. This is just data communication from the battery. This is not a wire that we're going to need to actually power anything. We just need to have some communication signal. So I'm going to be using the same wire that I use on iPhones. This is 44 gauge shielded wire. And I can't even hardly see it to work with it unless I put it under the microscope. This stuff is covered in an enamel coating, so we need to get rid of that to make it usable. It's pretty handy that it is insulated. I'm using 6337 leaded solder paste, and I'm just going to take a blob and use that blob of solder to clear off this wire. Here we go. Maybe I'll do it a little more graceful next time. All right, there's a bit too much solder left on the wire, so I'm going to reflux it like that, and then just use the iron to drag it back off clean. That's going to be good enough. So then, I'm going to do this in order. First wire, second wire, third wire, actually in reverse order. So the first wire, it's just going to get hooked right there. It will help tremendously to tin the pad first. In fact, let's just go ahead and tin all the pads. There we go. So the first wire is going to get hooked there. Now it is excruciatingly important not to squeeze the wire, because it will cut it. Okay, first wire. Second wire. Third wire. I'm probably making these a little bit too short. That's going to be okay. Now it looks like I'm going to need to clear off some more coating on this piece of wire because there's just not enough there. So let's get some more flux on here. That. Oh, wasn't that lovely? Okay, let's do that again. Starting right here. Nice big old blob of leaded solder. And just stick it through the blob. Like that. There we are. Okay. Now let's see if I can get that to tack down a little so I can, there we go, get a better hold on it. I'm going to leave that just like it is. All right, let's trim that off and then get rid of our flux. And then also get rid of this extra piece of wire. It would be very easy to destroy all these with a Q-tip. So we have to be excruciatingly careful. Okay, that's almost completely dry. I need to get rid of this little speck of crud that for whatever reason is on this wire. I think it's just burnt flux, but I'm not 100% sure. All right, so those jumpers are all looking pretty good, except for the one there at number 2. I'm not happy with that. I'm really not confident that that is going to stay where it's at whenever I go soldering it. So I'm just going to take and put some more solder on it. It causes me more cleaning, but I'd rather it be very solid and not have to worry about it. So I'm just going to hold on to that right there. Put more solder on it. There we go. That I can live with. That is much better looking. All right, clean that up again. Yeah, so I'm actually fixing this MacBook and recording the video on battery power. And not just like my laptop battery, but everything is hooked to this battery bank that I'm working on a review for. And so far, I'm pretty stinking pleased. So that is cleaned up the way that I want it. Now it's time to cement it into the board. And for that, I'm going to be using Mechanic Green UV Mask. I don't know why I use this brand. It's just the only brand I've ever had. In fact, I think this is probably only my second or third tube that I've ever had. I literally use tiny little bits of this. I mean, like super, super tiny little bits of this. So I'm going to cement all 4 of these down into the board so they don't come loose on me. All right, so there's those 3. Now I'm going to do number 1. All right, so that takes care of that. Now it's time to cure that up, and then once this stuff is hard as a rock, I can form us some brand spanking new pads. Lamp it, cure it. Go, go, go. All right, it's been a few minutes, and I can safely say that that mask is cured up. I was actually wanting to shoot for more of a rectangular shape out of these, but I'll pretty much take whatever I can get. All right, I'm just going to go ahead and call that good for the first one. Hopefully I can do a better job on the second one. So I'm going to start out by making a larger bend like that, because I'd really like for this to be more of a rectangle, like the pad's shaped, but even if we just had one single wire coming out and soldering to the pin, that would be okay too. So let's see if I can get more of a longer oval shape out of this one. And again, please remember you are looking at the tip of a number 11 X-Acto blade. That is the size of these little coils that I'm making. It's kind of crazy, really. All right, we got to go up and over the first one, and then down onto the pad. And for the next one, I have no more good ideas. We're just going to go for it. Try to make it about the same as that second one. Just trying to give us enough area to anchor the pins to. This isn't going to really be structural. This is just, honestly, we could just do a piece of wire. I could solder 4 wires out, just like I have now, glue that connector onto the board, and then bring the wires back and solder them to the pins, and it would be just fine. But no, instead we got to be fancy, right? This is what everybody does, only a lot of people do a better job than me at it. All right, let's get it up in the air, over the top of that second one, and down onto the board. I think, I'm tempted on this last one to spin it the other way. That would be kind of smart. So let's roll that one the other way. This sort of looks like hang on, almost there. Okay, and then we'll stop right there. You know, that sort of looks like what would happen if you handed a 2-year-old a crayon. It's going to be just fine. Here we go. Time for some green UV mask. And the size of the project is a little bit bigger than the tip of this toothpick that I'm using as a dipping bucket. And we're just going to want to make sure and cover all these pretty good and well. The goal is to get them cemented down to the board. All right, so there is the first one. Could actually do a much better job on these if I coil them up and then put them on the board. Because really where I get into trouble is trying to cross back over themselves. Yeah, I could just leave the wires sticking straight out and glue the connector on, and then bring the wires back and solder them to the pins. That would be most likely just as good. It would definitely look better than what I just did. I'm going to get in and nitpick a little bit on number 2 there, and just try to squeeze that in just a little bit flatter. There we go. So it's more lined up inside of its pad. Because I am going to scratch these off and form pads out of them. All right, there we go. I got our little snakes in there. And again, time for some UV light. All right, so I'm going to start on number 3 first here. Now we don't want to go so far that we cause any breaks in these wires. I just want to make sure that I've got something to solder the new connector to. And, you know, now that I see this raised up off the board a little bit, it may have made more sense to glue the connector down and then run wires to it. But either way, it's going to be fine. This connector is not going to care if it's not completely, totally flat on the board. And also, if there is any connection issues, then we can always install a jumper. So, okay, there's number 1. Two. Okay, let's move on. I don't want to go so far that I go through the wire, because I would like for these jumpers to work this time. All right, let's clean that up with some alcohol. I'm really not too proud of the way that turned out, but it's going to work just fine. All right, so I can't exactly call that brand spanking new pads, but I can call that brand spanking new globules. That's the new globules we're going to be soldering this to. So here's the old connector, and originally I told the customer that I would just be able to reuse the old connector because it looked like it would just sit right back in place and I could take, you know, what's left of the ripped off pads and just reuse this old connector. But as I looked at it farther and I flipped it over, I started to notice that the connector's actually cracked right there. And then on the bottom side of it, apparently Apple had part of this thing maybe glued down or something, because the connector, it's missing a big old chunk. And then it's also missing one of these ground legs. It's not actually ground, but it's just to make it more sturdy. And I'm not going to be reusing that old connector. So what that means for this video is that we're not going to find out if this mess that I just created is going to function, which it will. It'll function until I get the new connector. I am going to go ahead and check our diode mode readings to make sure we do have connections down inside the board. So red probe on ground on the first one. That was just a test point, so we're expecting that one to be open. The next one, I get a 0.43, that's normal. The next one, a 0.43, that's normal. The next one, we should get an open line, and we do. And for that one, I'm going to check it for continuity right to here, and I get a 0.00. So That is normal. And if any of that had not been normal, then I can just route wires to other places on the board. I could have just like glued the connector onto the board, which I'll be doing that anyways. And I could have routed jumpers from all over this motherboard to that connector, but that would just be kind of nuts since we can get those connections right there under the board. So anyways, let me know what you think in the comments below. If you want to see what happens, feel free to subscribe. I will post a follow-up to this video once I get the new connectors in, and we'll see if it works. I'll see you in the next one, everybody. Have a good day.